Thanks for coming. I'm here to talk about threat modeling stories from the trenches. Before I get started, I'll give the disclaimer that I didn't create all of these slides. A lot of this was created by some of my team members out in the UK who are unable to join me here in Texas today. Not all of these are my personal stories, though I did add some new ones from my catalog of history, so we can talk about those when we get there. The other thing I wanted to say is this is not a threat modeling talk where I explain to you how threat modeling is done. If you've never seen it before, cool, I'm glad you're here. But we're gonna kind of take a higher level look at kind of what types of things interest me and what we do when we're doing threat modeling, and to see how things maybe are a little bit different than might be assumed if you haven't gone through that approach before yourself. So about me, my name is Stark, hacker, gamer. Blockchain's been my thing for the past 2 years. I put anti-enthusiast because I like to tell people it's terrible and don't use it, it's just a slow database. Mainly because I'm afraid that if too many people use it, then everything's gonna go to hell. So it would be better maybe if we took a more reasoned approach towards new technologies in the future, but that's not going to happen. So, and then we like to call ourselves professional cynics because my job is to go to my clients as a consultant and tell them how they screwed up, or tell them that their assumptions are wrong, or tell them that they forgot about something, and just all around be the no guy. But then I stick around and I'm like, okay, fine, you probably still need to do business. You can't just shut it all down. So try to help them build it back up again. Okay, so like I said, I'm not going to dive into the whole methodology of how to do a threat model or how to build a practice out. But at the high level, right, we want to look at a system both at the whole, but also we'll talk a little bit about flow-based modeling as well. And kind of break the design on paper, right? We want to look at how it's working, what the assumptions were when we created it, what problem it's trying to solve, and what problems might come out of unintended consequences of the system. And then of course, fix the issues that we find, right? It's great to break the system, it's fun, but it'd be great if we could give some advice at the end. Okay. Like I said, we're not here to talk about the whole process, but we're just going to talk about kind of some cool finds that we have and maybe gain some insights about what makes a good threat model or what makes a good analysis of an already completed model. So first let's talk about what a design flaw is, right? So this is like some box that's holding some wires safe, and the door jams on the frame of the door, so you can't actually open it all the way. So whoever installed this, right, was just told, hey man, I need you to put this in the room, I need you to install this, bolted it to the wall and walked away and didn't think too hard about it. But that's not his job, right? His job isn't to test it, his job is to install it. Or, we can put in a stop sign in the middle of the road and it doesn't really do what we think it's doing, right? We're like, this is going to stop traffic, and then people just drive around it. And we do this with software all the time. It turns out it's just a little bit harder to see the tracks of snow in the software. Okay, so I've got a series of examples. Each one come with their own threat model, and I'm going to try to make this a little bit interactive and see if we can get y'all to solve the problem. Okay. So here's the idea. We've got a really basic application. It's got a client on the left, a DMZ that's running some reverse proxy that's probably giving us some controls. And then on the right, we have this protected perimeter network, right? This is very traditional AppSec. We're going to put a firewall on a DMZ, and then everything on the inside, is great. Everything can talk to each other. It's all cool because we vetted the people. And we've got a few controls, right? So our reverse proxy is actually doing a lot of work for us. It's doing mutual TLS, right? So it's actually authenticating whoever's coming in to a certificate that the client has. So it's not a password-based login. You can think of this as more of like a cat card or something with a certificate on board. Pretty solid, right? This is top tier, kind of what we expect out of a super important front-end application. And then the app server is actually going to be signing all of its messages with a signature based on whoever's logged in, right? So that way, if we go and look in the database, we can see, not only do we know that this data belongs to user A, but it's also been signed by user A. So even like the database administrator for that backend system or the secure log server, or like none of the DBAs or anything, they can't even forward user messages. It's impossible. Unless they steal the private key, but hopefully the user didn't put their private key on GitHub. And then the log server's cool too, because it's actually signing and encrypting log messages too, right? So every time a user performs an action, we attest that the user performed it by signing it with their key again. And that way, if there's an incident or if we suspect a user of wrongdoing, we can go back and say, you did X, Y, and Z. You're not allowed to do those things in that order, whatever. We're going to sue you. We're going to come after you. We can prove that because we have cryptographic hashes for everything. So this is really cool, right? We got some good security controls in here. So what can go wrong, right? So this is the first option for. I don't have anything to give away, so I have no incentives for you to answer my questions. However, I might give you a high five after the talk, maybe. Okay, so what could go wrong? Anybody? Any ideas how you might go about breaking this thing, or maybe something that was overlooked in this excellent control system? Yeah, key management's a tough one, right? Because ultimately here, the keys rely on the client to do the right thing, and then for them to like percolate through the system properly. So that's difficult. That's a difficult problem to solve. Though key management talk would be a much longer talk than I have time for. Any other ideas on what might be a problem here? Well, authentication's great because we got mutual TLS, right? So that's rock solid. I'm happy with that. Okay, this is a tough one. So the later ones might get easier. We'll see. So we have a problem with integrating all of our cool security controls, basically. So we have all of these signatures everywhere. We have this identity that the user has, but what's stopping me from changing my identity at different stages in the application? Right, so when we create messages in the app server or when we create logs in the log server, is there a control that's preventing me from saying, oh, I'm user A, now I'm user B, now I'm user C in each stage? And they're not integrating. Right? So when we look at who's sending the message, see the client's going to connect as A, it's going to sign their messages as B, so it ends up in the database as B, and then they're going to say, oh, but client C is the one who did all this madness, right? They have, what's happened is that the attacker on the left, the client machine, has generated 3 different user accounts, right? So they validly have keys for all these accounts. It's not like they hacked it or anything. But they're just causing confusion in the system, right? And what that means is that if we want to go back, say, after an incident, and say, we're going to use our excellent controls to figure out who done it, that might actually be difficult now. Because now we've got 3 whodunits, and it's not entirely clear, like, okay, so were these keys stolen from users? Were these keys compromised in some other way? Or were they just diversion tactics? What's going on? And so we spend a lot of time investing into new controls and new fancy ways of doing things securely that sometimes we miss the greater picture. And I think the threat model is one way that we can explore these more high-level issues as opposed to like a checkmark type compliance activity where they're like, you have to sign your messages, you have to sign your logs, you have to do this, and you get your stamps, right? And you walk down the line and now you're PCI audited or whatever. That's cool, but like it might miss the point. So this is what I like to have fun doing. Right, so what did we learn, right? So controls are not security. controls are products, controls are things that we buy or things that we invent, and they're necessary for security, but they're not the whole picture, right? There's something more here. Don't evaluate your controls in isolation, right? Like when I was going through that system on the first slide, when I talked about the 3 controls, I said, these are all great controls, right? These are all things that we want in our systems, or we would encourage others to put into their systems. But if we like put the horse blinders on, and we're like, it's good control, it's good control, we're going to miss it. And then, yeah, reviewing actually what ends up in the logs, as well as how it's protected, like what's actually being written. A lot of times when I do these threat models for my clients, we call them tabletop exercises. We're not supposed to look at code, but I like to look at code anyway, because the code tells me what's actually going on. I like to look at message schemas that are being passed around. Everybody's using JSON these days, which is great, because they have like Swagger files, and I can just like go get the Swagger JSON. It's awesome. Because then I can just be like, hey guys, why are you passing this correlation ID around everywhere? And they're like, oh yeah, we need it for auditing later. And I'm like, that's cool, but like, is it a good idea that I can correlate all of the actions of all these users together into a big pool of like, I just want to collect all the data? They're like, oh, maybe not. Oh. Okay. So example 2, we'll call this mind the gap. So here we're going to have a step-up authentication. So step-up is when you're like, say you log into your bank application on your phone, your mobile banking, and you have to put in your username and password to log in, maybe scan your fingerprint or whatever. And it gets you in, but then you want to do like, I want to transfer $10,000 overseas because there's a Nigerian prince who needs the money. And the bank says, hey, that looks weird and suspicious. We're going to require you to answer security questions, re-enter your password, scan your fingerprint, call us, text us, whatever that requirement is, right? So it's a pretty standard feature now, especially in high-risk applications like mobile banking, to have these step-ups. I've also seen it like on my Amazon. My Amazon stays logged in all the time on my home PC because I buy a lot of stuff on Amazon. And I never have to put in my password out to do anything. But if I change where I ship it to, like I just had a friend who got married, so I was shipping him his wedding present. Now I have to put in my password, I have to do verification emails, because they're like, you know, that's the first thing an attacker's going to do if they steal my account. They're going to ship them, they're not going to ship me stuff. Hey man, I bought you this cool TV on your credit card. That's not an attack. Okay. So that's what I'm talking about when I say step up. Okay, cool. So on the left we've got mobile app of some sort. I think this was a trading application, like a stock trading application. So they're trying to sell $10,000 worth of Acme Corp stock here. And it's going to go through the cloud, because everything's in the cloud. And we're going to hit this authentication layer, right? So this is our first security control. And our security control is going to validate that we're logged in, we're on Bob's account. That's going to be our victim today. And Bob actually, is allowed to hit this endpoint, which he is. Bob wants to trade $10,000, says the backend. Backend validates that Bob actually has $10,000 and all this. And the backend decides this is risky. We have to do a step-up transaction, or step-up authentication. So the authentication layer sends back a challenge to Bob. So say that's either a, you have to type in your one-time password, or you have to text us a number or whatever. It's some challenge. Bob completes the challenge, goes back to the authentication layer and says, okay, here's the response. And in this case, it's a one-time password. So this could be like an RSA token or a soft token or something. The authentication layer just validates the OTP, marks it as used. Very important. One-time passwords have to be one time, so you have to record all the ones you've used so far. But once that's done, it issues a new session token, because it says, here's your new, session plus. It's so much better than the last type. You don't have to type in your password again, and you can send the Nigerian prince all of your money. And the backend's cool with this now, right? Because it's got its increased session identifier. It's got Bob's account. It knows everything's good. No problems, right? Everything looks good, everybody? Okay. Well, before I ask you to figure out what we're going to do, I'm going to show you a couple different scenarios, and then instead of asking, I'm going to do like a raise a hand, see which one maybe we think is the best idea from an attacker's perspective, okay? So the attacker is going to try a few different things. The first thing the attacker is going to try to do is compromise your phone, right? If we have a man in the app or a man in the browser or a man in the phone or whatever it is, right, we're going after the device the user is using. That's an option. We could go after the communications link between the device and the cloud or in the data center or whatever. This would be like a traditional man-in-the-middle type attack. Or we could try replaying OTPs. So by raise of hands, who thinks the first option is the best idea? Okay, the second one? Oh, everybody's like, TLS is awesome. I'm not breaking TLS. And then the last one, relaying OTP. A couple, okay. Let's see how they do. Well, if we relay the OTP, the authentication server is going to reject it because, as I said earlier, it's validating this one time, so we can't replay. And if we could predict the OTP, there's much bigger problems for the system, right? If we knew it ahead of time, it would be an issue. The other two, right, if we go after the phone itself, that would definitely work, but we wouldn't have to bypass any of this, right? Because if I'm inside the app, I can just send requests at will, right? It's completely unnecessary for me to even bypass the step up because I can just tell the user to step up and force them to do it. So although that definitely would work, this would be a different threat model to determine how to prevent that, and we would probably have to talk about like attestation of phone integrity and TPMs and TEEs on devices and all that stuff. Okay, the link between the two, which no one wanted to attack, I tend to agree with. Anytime I see TLS on the internet, I'm like, okay, this is probably fine. You know, unless your attacker is a nation state, you're probably good. Though it kind of depends. There's a cool anecdote. Last year, I don't know if, like I said earlier, I'm a blockchain anti-enthusiast, so I have my anti-blockchain story. Last year, there was a story from My Ether wallet that got hacked, and their website's hosted on AWS. And what happened was some attackers hijacked BGP on the open internet to reroute Amazon's Route 53, which is Amazon's DNS service, to China or Russia or wherever it was. I don't remember where it was, to some Asian country. And then all they did is they had an exact copy of the My Ether wallet website. Users would go up there, upload their private key, do their Ether transactions, and they were just siphoning private keys. And they managed to do this for like 25 minutes before like global ISPs were like, I don't think Amazon moved Route 53 to Asia just right now. That seems weird. But it's surprising that like, you know, My Ether wallet's not a big website. This is not like, you know, the Google of blockchain. I mean, it's not that big of a website. In fact, it's really dumb if you're using it because like, don't upload your private keys to websites. That doesn't sound like a good idea. But anyway, it's a lot of people apparently use it. But somebody went after Amazon, big company Amazon, just to go after this tiny little website because they knew that they could collect easy money that way, right? I mean, once you get a private key for a blockchain cryptocurrency, it's just like, money's gone, right? It's mine. So if they could do the attack, it paid probably pretty good dividends. I think it was something like $25 million or so was stolen. Okay, anyway, that's a long story to say that maybe attacking the link between the things could work, but we're also not going to talk about that here. So I tricked you. The answer was none of them. So whoever wasn't paying attention and didn't raise your hand, congratulations. There is also this option. I didn't even offer this as an option, mainly because it doesn't work at all on any level. So the idea is like, okay, well, what if we just bypass the authentication layer and go directly to the backend? But you know, our backend's a little bit smart. It's like, I'm very suspicious of someone who doesn't have the authentication layer's IP address or signature or whatever. So we'll assume that that also doesn't work. Okay. So we need more options. Okay, what else can we do? So this is where I get into what I call flow modeling, where instead of just thinking about the system as a pile of components, which is what we've done so far, we've just been looking at what I call component model, now we can look at a state model or, well, like a swim lane diagram. right? So I'm sure if you guys are developers or security professionals, you've seen swim lane diagrams like this where we say, message gets passed one way, response gets passed the other, and so on. So this is going to be actually pretty simple, right? So far it's pretty obvious. You log in, you get a session token. Cool. We're going to call it session 1. That's our low-level session. That's not the stepped up. Then we do some action. Say I want to move $10,000, and we pass along session 1 with that request, right? And the backend decides that's a risky transaction and requests the step up, and the challenge is sent back to the user. And this is where it comes in, right? And we get a response to the challenge, and we get back session 2. Okay, so what's interesting here, right, is now we have 2 session tokens. And so how do session 1 and session 2 interact with each other? Like, how are they used by the overall system? So here's just in a different layout, right? Starting, signing in, getting your token, so on and so forth. So if I'm the attacker, right, I can log in on my account. It doesn't have any money in it, but I can do it. And I'll get session 1 _attacker and session 2 _attacker. Okay. And what would be nice is if I could skip all this other stuff, right? I want to go here because this is where I can move money. That's the fun part. So we want to step over everything. What could we use to do that? Well, let's assume that I compromise my victim's password somehow, right? So we're talking about OTP, right? So there's no reason to even talk about OTP if we assume passwords are perfect, but passwords are definitely not perfect. So, we'll just assume. Every threat model I do, it's just like passwords will be stolen, they'll be guessed, they'll be phished, whatever. Just assume the password's gone. That's why we're doing step up in the first place. Okay, cool. So I have those 3 things. Well, what happens if these 2 session identifiers aren't correlated to each other, right? Who's to say that the user of session 1 is the user of session 2? Okay. So this is what it looks like, right? So we're going to log in as the victim with, well, first, right, we're going to assume that we have these 3 pieces of information, right? So we're going to have our own sessions, but then we're going to use that password to log in as the victim. Okay? So now, after a login, we have session 1 of victim, and I've already collected my own session 2 of attacker. And we pass those along with the request to move the money, execute the trade. And then we have all of these, we'll call them microservices because that's the favorite buzzword these days. Lots of microservices in the middle. Whose responsibility is it to check, right? What microservice has the code that looks at these 2 things and validates it? And the problem that I think a lot of places run into, especially when we have this idea of distributed services or distributed responsibility across microservices is, well, the password system validates the session 1 because that's how you get session 1, is you send a password. And then the step-up system is responsible for session 2. And then the trade system doesn't do anything to do with authentication. All it does is look at your identity, right? So it's not clear to me that there is any system on here that has that responsibility, right? So when we were doing this model for our client, we were talking to them about the microservices, and we looked at their Swagger documents, and we could see that these were different microservices. So that's why we asked the question. We're like, whose responsibility is it to look at the big picture of the authentication sequence? Who's ensuring that the state flow is being executed faithfully and we haven't skipped steps? And their response was, we don't need to do that because we have all these microservices. Don't you see our cool microservices? Okay, well, because we passed in session 1 of the victim, and we've already sent in a stepped up session, the step up and the password authentication layers are going to be like, yeah, that looks good, right? You've done everything you needed to do. Welcome to the system, Bob. And then the question is, okay, well, the backend then actually does the trade. Which identity is it going to use for moving the account money, right? Is it going to use session 1 or session 2? Well, of course it's going to use session 1 because that's the only one that's guaranteed to be there, right? If he was only moving $50, it wouldn't require a step up and there'd be no session 2. So it only ever looks at session 1, right? So Bob wants to do the trade. Attack successful. Okay. Right. So again, right? The controls are not the end of the story. It's how the controls fit into the greater system, how they work together. And I think this is the key here is the responsibilities, right? Clearly drawing out responsibilities for every microservice or for every subsystem of your overall project. That tells you, am I missing something? You know, I'm the developer of the trade platform, and my responsibility is just do trades. I don't ever have to think about auth. But if I'm getting sent 2 tokens, and I know there are cases where I'm getting sent 2 tokens, you know, did I do enough due diligence when I was designing this to make that decision or not? And then this is kind of key to all threat modeling is what can the attacker do, right? That's, I think, what we're trying to get at when we're doing threat modeling is thinking like the attacker. Well, yeah. So they're using the user's password that they stole or phished to gain the identity, right? So now they are logged in as, and then in order to convince the step-up system that this session has been authenticated at the higher level, they pass in their own session identifier for the step-up identifier. They're 2 separate, say, cookies, or well, I'll call them JWTs because that's more in vogue these days. So you can think of the first JWT as actually having the user identity, email address, or user ID or whatever, and then a session token just being a Boolean that says step up equals true, right? And so since the second one doesn't tie to the user's actual identity, there's nothing to ensure that the second one was generated during this actual session, right? Like, do the session, like you can think of like having a timeline, right? Do the timelines match up? Did we follow, I gotta go back a bunch. Did we follow this process step by step? Or did we skip something? And in this case, we did. Like we logged in, and then after sign in, we just went to the end, right? We didn't, for that user, we didn't do step up. We just presented them an already gotten cookie. And it's like, oh, I guess you have it, you're good. You know, it's an interesting question to ask yourself when you're designing a system, is it's like, okay, right, so we have, like, say, a 3-step login process. You gotta type in your email address, and you gotta type in your password, and then you gotta do your OTP, right? And at the end of the whole thing, you get a cookie, okay? What happens if someone comes to the site and just has the cookie? Right? We've never seen them before, brand new IP address, brand new everything. They just show up one day with a cookie and they're logged in, right? So that seems really suspicious. There are certainly circumstances where that happens, right? Where, you know, they have a cookie because they got a new browser session, they closed the window, opened it again. There's some features for like Firefox where you can like move your session to your phone. That's an option. If they're in the car and they're driving, their IP address could be changing as they change cell towers. There's lots of things that can happen that way, right? But it's still worth the effort to go through it and be like, okay, well, in this particular circumstance around OTP, that doesn't happen. Or if it does, we just say, nope, let's just do it again. You know, how often does that happen versus what could happen if it goes wrong? Okay. Cool. Next one. So yeah, this one's funny because it's like really obvious that something's going wrong, but there's something, you know, it's much worse than what we can help them with. So when we first got here, we've got a web server in a DMZ and some protected network again with an app server, and we're just storing passwords in plain texts in the database. Right? So that's a no, we don't do that. So we're like, okay, new design. How about, instead of doing plain text, we just, you know, hash them and put them in the database. Right? Really simple, basic changes. No one should be upset about this, right? What could go wrong? And before I get into it, you know, I'll say, okay, the passwords are good, or the password hashes are good, right? We're using bcrypt with good iteration values, and they're upgradable in place, and all that fun stuff. Salted, everything. Cool. Until we get a call. Now, it turns out that the fraud detection system uses the user's password in their algorithms. Okay. Now, as a security professional, my immediate response is to like light my hair on fire and go, "What's wrong with you?" But I get it. Like, you know, if you're trying to come up with features, I would imagine that people who make fraudulent accounts probably don't pick the best passwords. They also probably share passwords across their accounts. So it could actually be kind of clever for an algorithm to just kind of decide that's a good feature to match on. It just doesn't really work in reality because we we need to securely store passwords. We shouldn't allow this to happen. But the fraud department doesn't call it the security department. No, the fraud department calls the developers because the developers screwed up, right? Broke their algorithm. So the developers fix it, right? So what do? Well, when the user logs in, we have their password, so we just put it in the session. And so now we've got a session database in the DMZ with all the passwords. Right. So, if we lived in the future where, completely untrusted environments existed and there were no DMZs and nothing trusts anything, the zero trust future we keep getting promised, this wouldn't be any worse than the first diagram because the DMZ wouldn't be a thing. It would just be another database in their data center. But because the DMZ is here, because we're saying that, this area up here has, more access from the open internet, we've lowered our security threshold here, right? We've said, here's more data. Hello, you're welcome. Not a great situation, right? So this is just kind of a quick one to kind of remind ourselves that as things change, as requirements get added, even in the middle of a sprint, right, that can have big changes to an existing threat model, right? So if you do threat modeling in an organization, it's important not to do it just once, but to have an iterative effect, or at least have a decision somewhere along the line says, have we made enough changes? Have we made security impactful changes that we need to go back and update the threat model? And the answer might be no, but that decision has to be made. Okay. More about OTP, because OTP is fun. So same idea, user logs into the cloud server, authentication server, OTP server on the back end. Password and OTP is sent at the same time, validate it in the back end, mark it as used. Attacker comes along, tries to replay it. Remember I mentioned this earlier and why this doesn't work, because it gets rejected, right? One time is one time, we can't use it again. Cool. Yeah, so we have a problem. Anyone have an idea of what I'm about to say?
Raise condition.
Raise condition. Yeah, well, kind of.
Like you write to the top one and read from the bottom.
Yeah, exactly. Yeah, so there'd be a raise condition if we actually had synchronization. But since we don't have synchronization, we're just going to desync the servers immediately, right? Because our good person's going to log in along the top line, and then my attacker is going to get routed to the bottom one and also be allowed in because these databases of used OTPs aren't being replicated or synced. And so we can put in sync, right? But the sync has to be good, right? We can't just be like, eventually it'll sync, right? And to be honest, that's how most databases work, is they don't have lockstep synchronization because it's really slow. But for things like this, you need that. Right? You got to try. I'm not a database administrator, so I'm assuming there's just like a checkbox to turn that on. But turn it on, right? So it turns out like this company, they did have synchronization, but I think it was like once a day they synchronized the servers, because this was just like another table in an existing database, and it wasn't a database that needed to be kept synchronized generically. And I think they had bought the OTP solution off shelf. And so the OTP solution doesn't support synchronization. That wasn't something that I don't even think that solution supported doing this. But they're like, it's just a REST endpoint? Psh, we can put that on the database server, it'll be fine. Yeah. Okay. Right, so deployment scenarios matter. Doing threat modeling in your dev environment doesn't do you much good, so don't do that. And if there are multiple instances of an app, it is a good idea to at least think about what could happen in that scenario. I will say that most of the time when we do threat modeling, if someone's like, yes, we load balance this service, I don't get into the nitty gritty of what that means and how they're doing load balancing and synchronization protocols and all that stuff. I might ask some basic sync stuff, but I'm not going to really get into it unless we have a situation where I think, hey, OTP's in play, or we have whenever the security control relies on synchronization, that's when we pull in that line of questioning. But if we don't think the control's relying on that synchronization, it's a better system for it, right? The less controls that we need to have in order to have a secure system, the better off we are. So I try not to bring in multiple instances if possible, but I have to be aware that they're there. Okay, playing well with others. So this one, this is the one that I added because this comes from a project I did a couple years ago. And it was probably the most severe bug I've ever found. And I found it in the threat model, and they didn't believe me, and then I pen tested it and broke it. So, yeah. So the idea here is that we have a company that wants to move to the cloud, but they don't want to like move into the real cloud because there's insecurities in the cloud. We're going to host our own cloud on-prem. And to do that, we're going to put a whole bunch of, well, I'll say these are containers. So a whole bunch of physical machines that are going to run containers on the right. We're going to have a NAS that stores all of our data. We're going to have SDN for all types of crazy networking options. And then we're going to buy an orchestrator product off the market. In fact, I think this one was open source, but I could be wrong. But so they have some orchestration software that orchestrates containers. But then it occurred to them that the orchestration product they purchased or were using is garbage at security. And they were told, look, you need to have single sign-on integration. Does not support it in the FOSS product. You have to have, you have to prevent users from creating privileged containers, which the product does not support. You have to provide app-level isolation, which the product does not support. So a sane person would say, we need a new product. But this team's like, no, I got this. I've got a security guy who knows Go, and he's going to write a JSON validator. So that's what happened. So on the left is a bunch of developers who write their code, right? And they create their Docker files and all their definitions, send it to the API endpoint, which is this validator thing. The validator, authenticates you to the SSO, right? Make sure that you've signed in through, I don't know, Azure Active Directory or whatever. Validates the JSON file as correct format and doesn't contain dangerous stuff like privileged flags or mounting network shares or things like that. And it implements the SDN rules for isolation, implements a shared or an unshared disk off the NAS, so you can get persistent storage in your container, but only for your app, right? Not for other apps, which is good. And it provisions you on a particular host. And then it sends that to the orchestrator, and then basically all the orchestrator does is just like execute the JSON file into Docker commands, and then you're done. Now there are all types of other issues, like their logs were just like hanging out in the wind and all these other issues, but like there was a bigger issue with the whole platform. And it all kind of comes down to they picked a product that had very few security controls and decided to implement it at this validator, right? So they implemented, like I said, SSO, security options in the validator, and then what they get is they get all these cool security controls on the right. Like the hosts are like, I don't even think the hosts had disks in them. I'm pretty sure they were just PXE booted to RAM. Like they were doing some really cool stuff over here on the right to make things as lean and secure and great as possible. But this whole platform is like falling on or requiring this JSON validator, which is like 200 lines of Go, to be right. Yeah, so what is my goal as the attacker, right? What can I do if I bypass these controls, right? Well, I could go to the NAS drive and collect all the data, right? So if I have access to any, like suppose I could write any container I want. I can create whatever JSON, there's no validator. Worst case scenario. I could mount disks from other projects into my project. So remember, this is all authenticated, so this would be like an employee at this company. This is a big company, it's got a lot of employees, a lot of developers, and a lot of apps. Some of them more critical than others, so this is not good. I could change the SDN, right? I could send commands to the SDN to give myself more access to the network, different like access to individual existing networks, or I could just turn off networks at will. I could just be like, hey, I want to be the default route for that network. That's an option you could set in your JSON file. And like, I could just drop packets, so I can do denial of service, I can man in the middle stuff. It's pretty good stuff. Or I can go after the bare metal hosts themselves. Like I said earlier, they're really lean, but they still exist. And I don't know how many of you guys play with Docker, but during this project, I got pretty good at doing container breakouts. So like giving myself full root privileges on physical machines just by spawning a Docker container is pretty easy. So I got pretty well versed at that. So that's a possibility. And just as a reminder, right, FOSS or COTS product and a homebrew API. And this came up in the threat model is we were like, look guys, you should probably get something more serious on the front end of this thing than whatever the hell, the dude in the cubicle wrote for you in 2 days. Maybe some more work needs to go into it. And so the question that I had for them, and I didn't get a good answer for, is how do we ensure that our validator matches the spec for the COTS product, right? COTS products have a lot of features, especially Docker products have a lot of features. So who's making sure that our validator actually knows all of those features and prevents any of the dangerous ones from happening? And the important part was when I pulled up the documentation and said, do you guys prevent this flag in particular? I just picked one. I think it was the one for mounting a disk, right? And you can specify network disks. So I was like, do you prevent them from changing this value? And they went, I've never seen that before. I'm like, oh boy. And it didn't occur to them that the attacker could read the documentation for the open source project. I mean, the guy who wrote the code didn't read the documentation, clearly. All he was doing was looking at the JSON files that had been developed in the past, and then just kind of being like, we don't want that, and we don't want that. So there was just like a blacklist for like, these are bad things. Like privileged equals true is bad. I'm like, what if privileged equals 1? And they're like, whoa. That took them by surprise. Anyway, so at the end of the threat model, they're like, okay, we get it. We're going to do better. And so now it's 400 lines of Go code. I'm not done. So I said earlier, I did a pen test of this because I was upset that they didn't do what I said, and instead did exactly what I told them not to do, which is just make the blacklist bigger. So I went and downloaded the documentation and started grepping through it for things like mount, port, volume, privileged, whatever. And what I found out is that this particular orchestrator supports an entirely different set of commands for doing all the things that the regular commands can do, right? So there's like standard JSON that Docker uses to describe containers if you use like Docker inspect. And that's what he thought this orchestrator takes. But the orchestrator has like, we have more value to add to this API. So they added another feature where you could just send it Docker commands to run. And it would just, system execute them on the metal. and I figured out that they were doing it right in that like I couldn't use that itself to like just get root, which would be funny. But yeah, I could just tell it to create a privilege container, and then it would do that, and then like reverse shell it back to me, and I got root on all the boxes, and I like could read from disks and change the SDN. And then they got mad, and I'm like, oh well. And my report told them to whitelist, don't blacklist, whitelist. And they went, that's going to be a no because that's hard. So 6 months later, they called us back to do a retest. And I copy and pasted my sample code out of my report, and it did not work. And then I changed one value to a different value that I knew from the documentation, and it did work. And I just called them, and I'm like, look, man, I broke your system in 15 minutes this time. Why don't you just like stop the project, or stop like paying me to do this? Stop that, go fix it, and then call me. Like don't do all these half-assed fixes. Yeah, so lessons, right? COTS is hard, and they need your help, right? Nothing that you purchase or download off GitHub is perfect, and nothing that you download or pay for will work in your environment securely out of the box. It doesn't exist. You actually have to do the work. You have to do the due diligence. Anybody who says it's got drop-in security, they're just selling you something, right? And that's cool, but like, ask the questions and get it done right. You probably don't know all the features your product has or might have in a future update. The particular values that I was using at the end of this project were not in the documentation. I just went and read the code because it was on GitHub, and I can see all of the options that it supports. And I'm like, look, guys, stop doing that and just tell your users what they're allowed to do, and then only support those options. And that goes to my last point here, is employing kind of known good templates is a really good way to constrain what you have to worry about in security. Making it easy to do things right, but making it really hard to do things wrong. Put it in an exception process. This is one of the reasons why they wouldn't do whitelisting, is they're like, well, we have some power users who really need these features. And I'm like, I'm sure you do. That's cool. They can pick up the phone and call you. They can insert a ticket into Jira and get an exception made. That's not that hard. How many of these people do you have? They're like, there's one team. I'm like, you have like 800 developer teams. What are you doing? Stop. Set the baseline. Tell them what they're allowed to do. And if they really need to do something different, you can help them. Be their friend. And I feel like this team in particular felt like they were the bad guy in a lot of situations. Like they were trying really hard not to come across as somebody who says no. And my message for them, which I'm 100% sure they did not listen to, is it's okay to say no as long as you help them do what they actually need to do at the end. Okay, last one, this one's quick, and I'll do this with a raise of hands as well. Actually, before I ask the question, why don't I define what an asset is, because I'm sure not all of you are seasoned threat modelers. So an asset is like anything that an attacker would be interested in your system, right? And therefore needs to be maintained. I like to call it the pot of gold. It's whatever an attacker wants, right? So this could be the subscription access, right? So if you're like home DSL or something, I don't know, people probably don't have DSL anymore, but whatever you have at home cable internet, that's an asset. Your download upload speed could be considered an asset in that I want to take your upload speed and change it to be slower so that you're bad at COD. Monthly data allowance could be an asset, right? If I use your internet to download my torrents, that would be convenient. And discovering where all your assets are is going to help you do your model. It's going to figure out what your attacker goals are. Because if you know what your assets are, you know what you need to protect. So going back to the question, is a username an asset? Raise a hand if you say yes. Raise your hand if you say no. Raise your hand if you're not paying attention. Okay, well, it was about half, but it's okay. Yeah. So everyone seems to think usernames are assets. This is an example that's kind of interesting because, how can you get to the top of the leaderboard? Anybody? How does Bob get to the top of the leaderboard if he's no good at the game? What if he just logs in as all the other users a bunch of times wrong and locks them out of their account? Right? So now they can't play the game anymore because they have to go fiddle with their Gmail, and Bob's gaming away and getting all the coins and getting the tokens or whatever. Right? And there's more examples than this. I was actually just reading about an old attack that I don't remember, but I think it was in 2006, 2004. It was a while ago, but it was one of the original versions of eBay would tell you the names of all the people bidding against you. And so someone figured out they could just go and lock out those users from their accounts right at the end, with a minute to spare. And so then they would win. And so that's why if you go on eBay now, it shows you first letter and then stars and then last letter. And I think Amazon does some of the similar stuff. Yeah, it's good stuff. So the answer is definitely maybe, right? Usernames can be assets. It depends on the system. Certainly not in all systems, though a lot of places are starting to use email as a username, or a lot of places do use that. And that's certainly an asset because that's a data leak waiting to happen. But yeah, not all users are equal, right? So your username that you see in your user interface is probably not your backend token used for your microservices backend APIs. So yeah, those aren't the same thing. But yeah, I hope you guys learned something today about threat modeling and design flaws, and that these aren't, what we talked about today are not theoretical things. These all come from actual work that me and my coworkers have done over the past few years. Doing a feature review is where you can start, but as you dig into these, think about them more, draw them in different ways, like drawing both the component and a flow diagram separately, and thinking about particularly the security critical flows, like one-time step-ups or money movement, things like that. Pick out what the risky actions are and spend more time there. That'll serve you quite a bit of benefits. Okay. Otherwise, I don't know why that's there. Questions? I can take questions. I don't know how long I'm allowed to stand up here. I'll be hanging out. I think there's like snacks in the hallway for the next 15, 20 minutes or something like that.
About 10 minutes, but first I wanted to give you a volunteer.
Oh, excellent.
This is a very nice jacket for you, so thank you for your time.
Good. Thank you. Excellent.